Welcome to the course Machine Learning with Imbalanced Data. In this course, you will learn techniques and tools that you can use to improve the performance of machine learning models trained on imbalanced datasets. My name is Soledad Gali, and I will be guiding you through this course. I am a data scientist, book author, open source Python developer, and the leading instructor at Training Data. As a data scientist, I worked in finance and insurance companies where I created machine learning models to assess credit risk, insurance claims, and to prevent fraud. You've probably heard that datasets to tackle fraud are imbalanced. In such datasets, the events we are most interested in predicting, that is, the fraudulent cases, are often underrepresented, which may pose a challenge in model training. Other examples of imbalanced datasets are those focused on disease diagnosis, where the rare disease we so want to diagnose is outnumbered by the healthy examples. Or consider also a dataset aiming to identify defects in manufactured products. Instances of defective items might be relatively rare compared to non-defective ones. So identifying these rare defects becomes crucial, but the imbalanced nature of the dataset can make it difficult for machine learning models to learn and generalize effectively. So why is data imbalance a problem? Machine learning models optimize balanced metrics by default. Imbalanced data can lead to biased trained models that tend to predict the majority class more accurately while neglecting the minority class, which happens to be the class that we are most interested in. There are three main strategies that have been used to tackle imbalanced data. The first one is introducing cost-sensitive learning. The second one consists in manipulating the training dataset through over or undersampling. And the third strategy involves using bespoke algorithms that have been designed to work with imbalanced data. And in this course, we will explore all of these strategies in detail. Among the undersampling methods, we have techniques that remove samples at random and methods that remove noisy observations based on different criteria. From the oversampling methods, we have those that oversample at random and those that create synthetic data, like SMOTE. All of these methods have advantages and limitations, and were also designed for specific use cases. So you will hear more about all of this throughout the course, including the risks of creating synthetic data or whether these methods are scalable. In addition, we will show you how to implement each one of these techniques in Python, leveraging the power of open source libraries like Imbalanced-Learn to streamline your workflows. All topics include hands-on Python code examples in Jupyter notebooks that you can use for reference, practice, and reuse in your own projects. So by the end of this course, you will be well placed to decide which method is more suitable for your data and your models, and then be able to implement it in Python. So who is this course for? This course is for data scientists or machine learning professionals who are currently working with imbalanced models and struggling to make them work well. And it is also well suited to students wanting to enhance their skills or preparing for a work interview where tackling imbalanced data tends to be a common question. So what will you take home? With this course, you will get lifetime access to over 50 lectures spread across more than 10 hours of video content. All topics include hands-on Python code examples that you can use for reference, practice, and reuse in your projects, so you will get lifetime access to the materials, ensuring that you're always up to speed with how to tackle imbalanced datasets in machine learning. So, would you like to know more about the course? Check the next video for a complete course curriculum overview. In the unlikely event that you don't find this course useful, there is a 30-day money-back warranty, so you can enroll today at no risk. So what are you waiting for? Enroll today and start tackling imbalanced datasets. See you on the course.